Make a flow proof. What's a flow proof? Is it like a flow chart, you ask? Kind of. Flow chart is like if I do this, then that happens. And if I do that, then this 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 happens. That's a flow chart. A flow proof is kind of like the same thing, but with statements and reasons instead. So I'm going to prove this by making a flow proof. What do I got? I am being told that segment AD is congruent to segment CE. So AD is U, congruent to segment CE, that's U, okay. And I need to prove that AC, which is U, is equal to DE, which is U. So segments that are made up of one or two more segments. Probably we're going to deal with segment addition, postulate, stuff like that. But I don't want to, take away from the excitement of finding out what's going to happen. Let's just get started. Segment AD is congruent to segment CE because that's the given. You always start out with the given. Now I'm going to put the given in a box. It all depends on what your teacher or professor or whomever, the book that you're using, wants you to do as far as flow proof stuff. But I like to put my reasons in the box. What's in the box? The reasons. 7. Also Incubus, I think. No, Hoobastank is the reason. They wrote that song. Very popular about 25 years ago when I was young. All right. It looks like to me that I'm starting out with segment congruent to a segment, distance equal to a distance. They probably want us to make things look like that. So what I'll do is I'll switch this up and make it AD is equal to CE and blame that on the definition of congruent. I said define. Oh, off to a banging start. Definition of congruent or congruence. But that's what I'm going to do. It's proper to do as many steps as you can, even if it looks sloppy. And in this, it might look a little on the sloppy side, but you know what? There's only like 5 of you guys watching this anyway. Now what? Well, I need to go from AD and CD to AC and DE. So how can I do that? How can I turn these guys into these guys? Well, AD includes AC because AD is AC plus CD. So let's say that. Let's say that AD is equal to AC plus CD. Now, when you take two segments and add them to make one more segment, that's called the segment addition postulate. I have a feeling that's going to happen again almost immediately. Postulate. All right, segment addition postulate. All right, so if I do that with AD, it makes sense that I should do the same thing with CE. So let's take this arrow, bring it up here. Look at me flowing. I'm going to say the same thing with CE, that CE is the same thing as CD plus DE. And that too is the segment addition postulate. The SAP, as people from Canada would say, because they like maple syrup. This is what I get for talking and punning at the same time. Postulate. All right. No more. I'm done. I'm done entertaining until I get this complete. All right, so now that I said what CE is, and now that I said what AC is, I notice that I have CD and I have AC, and I should be able to isolate them, right? My job is to get AC and DE all by itself. So why don't I get AC all by itself by subtracting CD? And why don't I get DE all by itself by subtracting CE? And I'll do that all in one big step. So what I will do is I will take this one. I will subtract CD from both sides to get AC all by itself. So AC, if I subtract CD, AC is going to equal AD minus CD. Similarly over here, if I get DE all by itself, it's because I subtract CD from both sides. So DE equals CE minus CD. All right. So now I have oh, and by the way, I did that because I subtracted stuff. So that is the subtraction property of equality. Subtraction property of equality. Let's put it in a box and draw an arrow up to here. Flowing once again, like a rapper. All right. So I need to get AC equal to DE. AC is AD minus CD. AC is CE minus CD. Oh, that's a shame. If only these guys were the same, then I could say that these were the same. Oh, wait a minute. AD and CE are the same. So if I take one of these, if I take DE, for example, and I replace CE with AD, I now have AD minus CD. And what I did is I rewrote DE equals and replaced CE with AD. So I use the substitution property. Running out of room, so I'll put prop. Okay. Now my last step is now that I know that DE is AD minus CD, and AC is also AD minus CD, that means that AC and DE are the same. AC equals DE. And I could use the transitive property. I could use the substitution property. I haven't used the transitive property yet today. By the way, the transitive property says that if A equals B and C equals B, then A equals C. That's the transitive property. So that works here. Transitive property of equality. I am done my flow proof. So I'm going to be honest, flow proofs aren't used a whole lot in geometry. They exist. They are done. You know, if you're taking a high school geometry course, you'll have a teacher do 1, 2, or 3 of them. Maybe have you do 1, 2, or 3 for homework. Maybe have you do 1 for a quiz, 1 for a test. But then they kind of disappear. If you're watching my videos one after another, you are usually going to run into 2-column proofs a whole lot more. But flow proofs are still out there. They still exist. And in a way, I did this the same exact way I would do a 2-column proof. These are my statements not in the box, and my reasons are in the box. It's just a different way that it looks. And in my opinion, it's uglier. But I'm not here to judge beauty. That's up to judges of beauty pageants. Like and subscribe.